Hello, everyone. Uh, okay, so this is section 6.7 and 6.8. Since the exam is on Thursday, so I'm combining Monday and Thursday lecture in this video. And also, this is going to be the last video of this semester. All right, so maybe I might make some review videos later on, maybe after Thanksgiving break. I'm not sure, or maybe I'll just give you guys just the review problems uh, later on. But uh, but the official lecture is this is the last lecture. All right. Okay. So again, I just want to remind you guys about the exam and about the thing that you guys probably will see in the exam. Okay. So the exam is, well, you guys know probably uh, by now that the exam is Thursday, November 19. I will, well, you guys will be able to see the exam at 5:30 p.m. I'm not sure how much time I'm going to give you guys. I'll decide that later, but definitely read the instruction. All right, and I think I've already told you guys this before. Right? It's going to be over 5.4 to 6.6, 6 and 5.4 to 6.6, and this one, well, I've been saying every time. All right, again, it will be similar to the examples and concepts that I showed in the lecture videos, and it will also be similar to the wave assigned homework problems. So this time I'm not going to give you guys any review. All right. Uh, because I feel like I don't really have anything to give for the review. I have pretty much done the examples I wanted to do, and I've also talked about that in the videos. So if you guys have really watched my videos, then uh, you will definitely know that what I've talked there. So yeah, it will be similar to those examples. All right, so please go over the examples, all the examples and the concept I talked in the lecture. And also if you have done the homework, then probably you know what kind of problems you might see in the exams. All right. And okay, the web assigned homework 6.4, 6.6 is due this Wednesday. Okay. All right, so let's get started then. Okay, so first I'll be talking from section 6.7, which is about hyperbolic function. I will. There are lots of things in that section. I will just talk a few things from 6.7. All right, and also a few things from 6.8. All right, so the first thing I want to talk is a hyperbolic function. So the hyperbolic function, basically the hyperbolic function, this is how we write sine h. If you just write sine x, then it's a trigonometric function, right, or trig function. But if you see h here, like this, then we say this is hyperbolic function. So a hyperbolic function, sine h x is this e to the power x minus e to the power negative x over 2. Similarly for this one is this. Now we'll be focusing on derivatives. All right, so the derivatives of hyperbolic function, well, I basically copied this from the book. Well, this is this is a formula, right? So the derivative of sine x or hyperbolic sine x is cosine hyperbolic x, or you can even say hyperbolic cosine x. And the derivative of hyperbolic cosine x is hyperbolic sine x. So yeah, you can just read this. All right. So yeah, and then another one, the derivative of inverse hyperbolic function. So again, these are also formulas. So the inverse, this is well, yeah, we say this as hyperbolic function, right? And if I put something like this on the top, then we say this is an inverse, right? So that's why we call this inverse. All right, so yeah, again, this is also formula. All right, so here I'll be just doing one example. All right. So the reason I'm not doing lots of examples are because, um, well, the technique is going to be similar to all those product rule, quotient rule, chain rule. All right. It's just that now we have new formulas here. All right. We just have to apply this formula here. That's it. But the technique are similar to these, what we have already learned in chapter 2. All right. So even though I will be doing just one examples, and the exam I might ask some problems similar to the quotient rule. All right. So maybe you will see that in the web assigned homework. Okay. Okay, let's do this one. Okay, so so here, so what can we do with this one then? So since we have, okay, so since we have tan hyperbolic tangent or hyperbolic inverse tangent cosine x, right? So, well, we know that the derivative of hyperbolic tangent x, or the inverse of this, the derivative of this one is 1 over 1 minus x squared, right? But now here, instead of x, we have this whole cosine, right? So when you take the derivative of this one, it will be 1 over 1 minus cosine square x, right? Instead of x, now we have cosine x. That's why I have cosine x and square of that. All right, now times, now using chain rule, now we need to take the derivative of cosine x, and the derivative of cosine x is negative sine x. All right. So the derivative of sine x is positive cosine x, right? And the derivative of negative, or sorry, the derivative of cosine x is negative sine x. Again, I have talked about this in one of the lecture. I don't remember, but it was on the trigonometric functions lecture. All right, so this is a formula. All right. So anyway, now what can we do after this? Well, what can we say for this one? So, well, we know that, again, this is also the fact from trigonometry class. All right, so sine squared x plus cosine squared x is equals to 1. All right, so, and if I move this to the other side, sine squared x is equals to 1 minus cosine square x. So that means 1 minus cosine square x is also sine square x, right? So on the top, we still have negative sine x. On the bottom, we have sine square x. So when we cancel these two, it will be 1 minus sine square x. Okay, and you can leave your answer here. But if you know, again, another, if you guys remember another formulas, another formula from trigonometry class, 1 over sine x is cosec x. All right, but if you want to leave your answer here, that's fine. Okay, but this is also, well, if this is cosine cosec x, then there is a negative, so negative cosec x. Okay. All right, so yeah, that's all I want to talk from 6 and 6.7. It's just that there is a new formula. All we have to do is just apply this formula here, and this is also similar to the one I talked from inverse trigonometric functions. All right, similar to those. So I have done a little more examples there. All right, so again, there is nothing new here. The technique are same, just that we are applying new formulas. That's it. So that's why I'm not doing lots of examples. Okay, but you might see a little more in the web assigned homework, and also probably in the exam as well. Okay, so now 6.8. 6.8 is going to be L'Hopital rule. So L'Hopital rule, we're going to apply this L'Hopital rule in the limit. All right. So here, let's go over some fact. Okay. So now, if we have, or if you're taking the limit of something uh, with this kind of functions, uh, f of x divided by g of x, and if we take when you take the limit of that, if we get 0 over 0 or positive or negative infinity over positive or negative infinity, if you ended up getting this kind of case, then what we got to do is we need to take the limit of that by taking the derivative of just the numerator divided by the derivative of just the denominator. All right, so let me show some examples so you know what I'm talking about. Okay, so using that fact, okay, so now let's see what is the limit of this one. So, all right, so based on what we have learned so far, so the limit of this one will be, so if I plug this in, or let me do it here, if I plug this in here, so it will be on the top, it will be limit of 1, right? Sorry, the limit of, sorry, if x goes to 1, then it will be natural log of 1 over, on the bottom it will be 1 minus 1. So on the top, well, if you input this, put this in a calculator, natural log of 1 will be 0. And on the bottom, 1 minus 1 is also 0. So we got this 0 over 0 case, right? So if you have this case, then what we're going to do is we have to take the derivative of the top and the derivative of the bottom. This is not product rule. We are just taking the derivative of just numerator and then just denominator. Okay, so using L'Hopital rule, or I see in some book they even call it L'Hospital rule. All right, but yeah, same thing. If you say L'Hospital or L'Hopital rule, it's the same thing. Okay, now applying L'Hopital rule. First, okay, this limit of x goes to 1. Okay, now take the derivative of just of the numerator. So what is the derivative of natural log of x? Do you guys remember? The derivative of natural log of x is 1 over x, right? Again, I've talked about this definitely in this chapter 6, but I don't remember the exact section. But if you have watched all of my lecture, probably you guys know it. All right. So on the top, we'll get 1 over x. And on the bottom, okay, the derivative of x is just 1. The derivative of 1 is 0, so we don't have to write that. Okay, now let's see if we ended up getting 0 over 0 or infinity over infinity. If not, then whatever we get, that's our final answer. So if x goes to 1, so x goes to 1, it will be 1 over 1 is 1, divided by 1 is 1. So our final answer is just 1. Okay, so that's how we use L'Hopital rule. Okay, now the next one. Okay, now let's next one. Let's do this one. Okay, so now here x goes to infinity. Okay, so if x goes to infinity, on the top, infinity square, well, infinity square is also infinity, right? Infinity square, well, the really, really big number, infinity means it's a really, really big number, right? So the big number, and if you take the square of that, is also a big number. It's a huge number, right? So that's why infinity plus, well, whatever we have, definitely we're going to get infinity on the top. And similarly on the bottom, infinity cube, again, it's infinity plus 1. It won't make difference, right? Infinity plus 1 is what? It's still infinity, right? So that's why it's infinity. So then, okay, we got this infinity over infinity case, right? Infinity over infinity case. So now again, we need to use here L'Hopital rule. So using L'Hopital rule, just take the derivative of numerator first. Again, we are not using product rule. It's just that we are taking the derivative of the top and then derivative of the bottom. Okay, so the derivative of the top here, x squared will be 2x, right? The derivative of 2x is just 2 over, this will be 3x squared. Derivative of 1 is 0, so we don't have to write that. Okay, now let's see again. So if x goes to infinity, so infinity, 2 times infinity plus 2 over 3 infinity square. Well, infinity times 2 is still infinity, plus 2 is still infinity. Infinity squared is infinity times 3 is also infinity, right? Again, we have infinity over infinity. So again, so we need to use L'Hopital rule second time. Okay, now again, let's take the derivative of now this one on the tops, which will be 2x is just 2. On the bottom, it will be 6, right? 2 times 3 is 6x. Okay, now let's see what we'll get. So now we'll get 2 over 6 times infinity, right? So that means on the bottom, 2 over, on the bottom, we'll get 6 times infinity is still infinity. So 2 over infinity is what? So a really small number, let's say 1 divided by, for example, infinity is a big number, right? 1 over, let's say, 1, 0, 0, 0, 0, 0, 0, 0. So what will this one be? So it will be 0.0000000, something like that, right? 1. It's a huge number. So, well, infinity is even bigger than this. It's a huge number, right? So in this case, 0.000 is similar to, practically it's similar to 0, right? So that's why any number divided by infinity is 0. Okay, all right, now let's do another one. Okay, so another one is, okay, this one now. Okay, so now let's see. Okay, now here x goes to infinity. So if x goes to infinity, it will be e to the power infinity over infinity square, right? So e to the power infinity, e to the power a big number is also a big number. And infinity square is, again, it's a big number. It's infinity. Okay, so we have infinity over infinity, so we can use L'Hopital rule. So using L'Hopital rule, okay, if I take the derivative of the top, the derivative of e to the power x is still e to the power x, right? And the derivative of x squared is 2x. Okay, now let's see what we're gonna get here. So x goes to infinity, so again, on the top we have e to the power infinity, 2 times infinity, which is also infinity over infinity. So again, we need to use L'Hopital rule. Okay, again, now I need to take the derivative of the top from here and the derivative of the bottom. So x goes to infinity, the derivative of the top is, again, the derivative of e to the power x is still e to the power x. The derivative of 2 is, sorry, 2x is 2. Now, okay, so now after this, x goes to infinity. So e to the power infinity over 2. Okay, so on the top, we have infinity divided by 2. So infinity divided by 2, well, it's a big number, divided by 2 is still infinity. Okay. All right, so yeah, probably you guys understand the idea, right? So, so the only time we are going to use this thing is when we have 0 over 0 case or infinity over infinity case. Let's say if we have x goes to, let's say something like this, 1, x squared plus let's say 2 over x minus 1, something like this. Well, on this one, can we use Al Hospital rule or not? So if, let's see, so in this case, if x goes to 1, it will be 1 square plus 2, it's 3 over 0. So 3 over 0. So, well, we don't have 0 over 0 or infinity over infinity, right? Or positive infinity or negative infinity, or positive infinity, negative infinity. We don't have that case. So in this case, we cannot use L Hospital rule. So here, a number divided by 0 is undefined, right? So the limit here is undefined. This kind of problem. All right. Okay. So yeah, that's all. Okay, so like I said before, the exam is this Thursday. So probably after your exam 4, I will email you guys the final exam review, or maybe I'll email you guys the review, final exam review, and then the final exam is on Thursday after Thanksgiving break, right? So I'll definitely let you guys know through email. I'll remind you guys about that later on. But yeah, for right now, focus on exam 4. Like I said, the exam problems will be similar to web assigned homework and the examples or the ideas I've taught, what I did on the lecture. Okay, yeah, that's it. That's it for this one. Thank you.